Okay, so hello and welcome back. So we get to chapter 11 of class 1, and so in this chapter we will talk about basically multiplication. Now, when I went to school, when I went to school myself in primary school, they don't really, they didn't really discuss much of what I'm discussing here. They didn't discuss any of this over there. It was just like for example, when it came to multiplication, what they did is that we had a teacher, and she essentially she told us to go home, and she gave us essentially a bunch of multiplication tables, and then we were supposed to go home and just keep writing and rewriting those tables in order to memorize them. And of course, I never understood what multiplication actually represented. And well, until later on that I started studying mathematics myself, after which I started to understand what multiplication actually is. Now, when you know that essentially the actual meaning of multiplication, you know that it's essentially nothing but essentially the addition that we have learned using these models of beads and Gin-Laddis and things like that, basically. So essentially the same addition that we have learned so far, when you when you do it repeatedly, it becomes multiplication, as we will see shortly. Okay. And well, like me, I would say 95% of people never understand the actual meaning of multiplication. And of course, if you don't understand multiplication, there is no way that you're going to understand calculus, because of the fact that calculus essentially is nothing but these four basic operations in mathematics, but they are used very cleverly over there. Meaning that calculus has kind of has this mind of itself. It's like a machine that essentially puts automation on these four basic operations, and then once this is done, then of course these then you have essentially practically have automated these basic operations. You don't have to do it yourself. Calculus is essentially doing it for you every second, or essentially every moment, and then this machine keeps turning and turning and turning, and that's the beauty and the power of calculus. And of course, this machine, or this mind that calculus has, that uses in order to automate basically these basic operations, it doesn't have it itself. Basically meaning that this machine doesn't belong to calculus itself. Calculus essentially borrows that machine from algebra, meaning that calculus is borrowing algebra as a machine, and this machine is just keep moving and moving and moving every moment. Now what this machine does is that it takes control of these four basic operations: addition, subtraction, multiplication, and division, and automates them. So then you don't have to do it yourself every second, and as a result, then you can essentially calculate the instantaneous velocity of some object, or essentially in general you can essentially then calculate the rate of change of anything, right? You can do it forward, you can do it backward. It's just this amazing machine that borrows its power from algebra, and then algebra comes and uses these four basic operations in order essentially to do all that calculus does. Okay, so it's very important to understand, otherwise I wouldn't have wasted our time on these basic things, but they are really important. Okay, now if we come back to multiplication, Now we have essentially something like a short story here, only a couple of pages, and it's a visit to an amusement park. A group of children visited an amusement park, and there is this this game kind of thing over here, and then there is essentially these horses, and then children can sit on those horses, and then it keeps essentially revolving, basically, right? Now it says that here, it says that about 2 of us can sit on the horse. I will sit with my friend. So that what she's saying is that it's essentially on every horse 2 people can sit, which means that if I have essentially one horse, two people can sit, another horse 2 people, another horse 2 people, another horse 2 people, and so on and so forth. So which means that essentially the total number of children that can sit would be essentially a 2 plus another 2 plus another 2 plus another 2 would be 2 plus 2 plus 2 plus 2, which is an 8, right? Now suppose that so essentially then we can say that 8 of us can sit on the horse swing all together, on the whole basically horse swing. 8 people can sit. Now you can imagine that, of course, calculating this would be easy. There is no problem with that. You can say 2 plus 2 plus 2 plus 2 is equal to 8, and that's it, right? That takes only a few seconds. But then suppose that, for example, there is this horse swing, and on this horse swing there is, I don't know, 1,255, for example, of these horses. And on each horse then, I don't know, 3 people can sit. Then you want to calculate how many people can sit on the whole horse swing. Then you would have to say essentially 3 plus 3 plus 3 plus 3, 1,000, I don't know, 1,300 times, for example, something like that, right? And then you have to just keep adding and adding and adding, and then it would take you probably a couple of weeks. And so of course it's not possible to do things like that in mathematics. You have to be able to essentially put automation on things. You have to be able to automate things and calculate things in more, essentially, in easier ways, right? And I mean, if you watch, there is a movie, the Man Who Knew Infinity, which is about, it's a movie about Ramanujan, a very famous mathematician from India. And for example, back then in 1912-15 or so, back at those times, for example, there is something in mathematics called partitions. And essentially, back then, for example, there was essentially no formulas in mathematics to calculate partitions of a number. And so essentially the mathematicians had to sit and calculate things for weeks altogether in order to do the partitions of, for example, the number 200. That's essentially all the different ways that you can essentially add different numbers together to get to the number, for example, 200. That's all the partitions of 200. And it would take them, for example, 2-3 weeks. They would have to just sit and do the calculation by hand in order to get to such kind of calculations. Okay. Now, now there is essentially these 3 compartments over here on this train, and in each compartment 3 people can sit. So 3 people sit here, 3 people sit here, 3 people sit here. So that means that essentially the total number of people that can sit here would be 3 over here plus 3 over here plus 3 over here, which would be a 9, right? So then the total 9 children can sit in 3 bogies. Again, over here, if you had, for example, a couple of thousands of these compartments, then again calculation would be just simply impossible, right? It would take you forever to calculate that. So again, for example, over here you see that on this merry-go-round there is essentially one compartment here, 2, 3, 4, 5 compartments, and in each compartment 4 people can sit, meaning that the total number of people that can sit here would be a 4 plus another 4. So let me see, 1, 2, 3, 4, and 5. And there must be something wrong here. There must be something wrong here. There are 5 compartments, so there must be 5 of these. But anyhow, the total number would be a 4 plus a 4 plus a 4 plus a 4 plus a 4 5 times, which would be essentially in total would be 20 people, right? These essentially there is these trays of sweets, and each plate contains essentially 3 pieces. So there is 3 pieces here, 3 pieces here, 3 pieces here. So the total number of sweets that we have here would be 3 plus 3 plus 3 plus 3 plus 3 plus 3, 6 times, which would be 18 sweets altogether, right? Now again over here, it would be impossible to calculate the number easily if you had, for example, I don't know, 2,600, for example, plates. Then you would have to do this. You would have to essentially add these numbers together, for example, 2,600 times. It would take forever. Now another essentially the way to make this simple is essentially is essentially by doing multiplication, right? So when you multiply, what you say is that basically we have essentially this plate over here. It contains 3 sweets. Again, we have basically all of these. So that's a 4. That's basically a 6 basically plates of sweets. If I want to calculate essentially the total number of sweets, that would be 3 plus 3 plus 3 plus 3 plus 3 plus a 3, which would be essentially 6 times, right? That would be 6 times. And basically, and that would be essentially so 3 plus 3 is equal to 6, 3 plus 3 is equal to 6, 3 plus 3 is equal to 6, and then 6 plus 6 is equal to 12, and 12 plus 6 is equal to 18. So this whole thing essentially becomes 18. So now instead of saying 3 plus 3 plus 3 and so on and so forth 6 times, I can say 6 times. I can say 6 times 3 is equal to 18, right? That's essentially the exact same expression that I've written over here. What I've just written, I have just essentially reformulated that. So instead of writing 3 plus 3 plus 3 6 times, I can say 6 times 3 is equal to 18. And I already know what that is, so that's essentially 18, right? Or basically, for example, over here, you have basically 2, 4, 6, 8, 10, 12, 14, 16, and 18. So essentially, you have essentially you have this bus. You have this bus over here, and the bus essentially it has 1, 2, 3, 4, 5, 6, 7, 8, and 9 seats, right? So we have 9 seats over here. Each of the seats contains basically it can seat basically 2 people, right? So which means that essentially the total number of people that can sit in the bus would be essentially 2 people here plus another 2 people here plus another 2 people here, and so on and so forth. And you have to do this 9 times because of the fact that essentially you have 9 seats, right? So then this would be essentially 2 plus 2 and so on, so on, so on, so forth, essentially 9 times. Which would be essentially, if you do this calculation, this would be 18, for example. Now instead of writing this very long expression, essentially of addition, I can just simply write 9 times 2 is equal to 18, right? So again we have the same story. So we have 2 plus 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 2. So this is 6, 3, 6 and 9. So this is 9 times is equal to 18. So then instead of writing this very long expression, I could say 9 times 2 is equal to 18. And instead of writing 9 times 2, I can write 9 times 2 is equal to 18. That is the meaning of basically, that is the meaning of multiplication. Of course, you're supposed to, ultimately you're supposed to memorize these numbers, right? But then again, memorization is not really important, because you essentially review it a couple of times and you learn it. And then as you work with your mathematics, you will essentially learn all of these automatically by heart. So the memorization part is necessary a little bit, but of course before you memorize it, you have to understand the concept itself, right? So then basically that's that. Or for example, we have these crates of water bottles, that each of the crates contains basically 5 bottles. Basically you have 5 bottles here, 5 bottles here, 5 bottles here, 5 bottles here. So in total you have 5 plus 5 plus 5 plus 5, essentially 4 times, which would be essentially a 20, right? So then you can say that instead of writing essentially 5 plus 5 plus 5 plus 5 4 times, you can say 4 times 5 is equal to 20, right? That's basically that. Or for example, over here you see that there is these packets of erasers, and each packet contains essentially 2 erasers. So the total number of erasers would be essentially a 2 plus a 2 plus a 2 plus a 2, which would be essentially 8 erasers in total. So then instead of again writing this long expression over here, I can just simply write 4 times 2, essentially 2 plus 2 plus 2, essentially 4 times. So 4 times 2 is equal to 8, right? So the total number of erasers would be 8. Or essentially, for example, over here you have these packets of pencils, and each packet contains basically 3 pencils. So then the total number of pencils would be essentially 3 plus 3 plus 3 plus 3 plus 3, 5 times, which would be essentially 15 pencils in total. So then again, instead of writing this long expression, we can write 5 times 3 is equal to 15. Or the total number of apples you can calculate here, 3 plus 3 plus 3 is equal to 9 apples, which would be essentially 3 times 3 is equal to the total number of apples, which would be 9, right? So this is the meaning of multiplication. I hope you've understood it properly, and I'll see you in the next video. Thank you.